Hey everyone, welcome to week 8. We're almost to fall break. Yay, I'm very excited. This week's videos in Algebra 1 are going to be pretty short. You should have picked this up in class. If by chance you didn't, then there is a copy of this available in the week 8 folder. And if you don't have a printer, just get out a piece of paper, write on it, and bring it to class, or the other option is to upload it. So I would prefer my Thursday, Friday students to bring it to class, and I would prefer my Tuesday, Wednesday students to upload it. But in the end, you can bring it to class, you can upload it, I guess whichever's going to work best for you, okay? But this is going to be worth points. When I do this video today, I'm not going to be doing every single problem with you. I am going to leave some things for you to do. You will need a calculator because we're going to be doing average rate of change as well. I think I covered everything, and then bring your note packet to class because we're going to be taking notes in class. All right, so let's take a look at what this says. It says below it models the height of a ball. The label for the x-axis is time in seconds, so I'm going to write that on my graph. I'm just going to abbreviate it. And it says the label for the y-axis is height in feet, so I'll put that over here. And we're going to answer the following using complete sentences. So, some of them we're not going to. That's not exactly what I'm looking for. We'll talk about the complete sentences. So, for what intervals of time is the height of the ball increasing? So, before we start answering these questions, I've got this whole shape called a quadratic, and I actually don't need all of it. So, one part that I don't need is this side, because over here, my time is negative, and I don't need that. The other part of the graph that I don't need is this lower part that I'm covering up, because then my feet are negative and the ball's not going to go through the ground. So we could always say it's in the water or something like that, but we're not going to do that. So this is actually the only part of the graph that I need. And when you ever do a graph in context and we're describing it, you will have to think about that I might give you an entire shape, but you're not going to need that entire shape. The next thing we're going to do is we're going to mark our points. So these are going to just be estimated very general. So we're going to say that this point is about 0 and 110. Where it turns is another important point, and we're going to say that this is 3 and 250. And then where it lands, we're going to say this is 7 and 0. So you always want to mark where it starts, where it stops, where it turns, and any x-intercepts, which we already got. So for what intervals of time is the height of the ball increasing? Again, I know it says this, but I really want us to practice with the inequality symbols. So x is time. You can use x, you can use t for time, you can use s for seconds, you can actually put the word in there, but we always use it with the 2 less than signs for between. So I want to look at where the height of the ball is increasing, and in this stretch it's increasing, and in this stretch it's decreasing. So I'm going to put the x value where it starts, and then I'll put the x value where it ends. Okay? All right, so this one is new. For what interval of time is the height of the ball positive? Well, in our scenario, I've discussed with you that we actually don't want this area or this area, because those would be, over here is negative time, and the height is also negative. And then over here, even though we have positive time, which is what we have always, the height of the ball is negative. So in this whole scenario, the height of the ball is positive. So again, I'll put, this time, let's use t for time. And I'm going to put where it starts, and it's positive, 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 all the way until it gets to here. And again, we're not underlining. The only time I ever want you to underline these inequalities is when we're talking about domain and range. Because an example of why I wouldn't underline here is because underlining means I'm including that the height of the ball is positive. And when I get to here, the height of the ball is not positive. The height is 0, and 0 isn't positive or negative. So just some things to keep in mind. I'm going to let you answer this one. And I'm going to let you answer this one. All right, so you're going to have to look at your graph to do those. Let's talk about E. What is the maximum height of the ball? So this is something, the maximum height is where it's turning. So we're going to say 250, and make sure you label, and you're going to need to label your answers here. And at what time is the ball at its maximum height? I'm going to say 3 seconds. All right, so G and H. I'm going to let you do G, and I'll do H with you. So remember, domain is your X and range is your Y. So on H, they want to know what is a reasonable contextual range for the situation. So for what values of height does the graph make sense? And we've already discussed that. This pink part is the only part of the graph that I want. So for range, I'm going to put my Y. I could put H for height. I could put F for feet. And I'll do my between. And I want to put the lowest height of the ball and the highest height of the ball. And again, when I do that, since Y is up and down, I take my pen, and the first important point that my graph hits is here, and the lowest the height of the ball is 0, and the highest height of the ball is when I get to the very top is 250. And I'm going to put 0 and 250. And again, this is range, so I will underline because 0 is a height. It's an actual point on our graph, and so is 250. All right, let's talk about this one. Find the average rate of change of the ball during the first second. So that means from 0 to 1 second. And whenever we do average rate of change, I will give you the X and you will somehow have to determine the Y. So in this case, we're going to determine the Y by looking at our graph. So we already know if X is 0, our Y value is 110. But now I'm going to have to look at my graph, and if X is 1, sorry you can't see that, my Y value is about, it's not quite 200, I'm going to say maybe 190. Okay? And if you think it's 200, you can do that. It's no big deal. So remember, average rate of change, AROC, is just slope. It's where I take my Y values, subtract them on top, and however I subtract those Y values is how I will subtract the X values in the denominator. So I get to decide, do I want to do 110, take away 190, or 190, take away 110? And I always prefer to have the bigger number and then subtract the smaller number. So if I subtract those, again, you can use a calculator here, that's 80. But now I'm going to have to realize, since I subtracted 190 minus 110, I'll have to do this the same way. And that's why you see these little 2's and 1's here, 2's and 1's here. That is saying, make sure you subtract the same way. So I'll take 1 minus 0, which is 1. And then our goal is to always make sure our average rate of change has a denominator of 1, which it does. If it didn't, let's say this denominator was 3. And I realize this is kind of hard to see. Let's see if we can tone it down a little bit. There we go. Then I would just take my numerator and divide it by my denominator, and that would become my average rate of change. But it's over 1, so we're okay. All right, the one thing it doesn't say here that I'm going to make us do is, what does that mean in context? Because that's going to happen most likely whenever our graph's in context. So you need to remember that everything in the numerator is a Y value, and that our Y value is the feet. It's our height in feet. And everything in the denominator is an X value, which is our time. It's our seconds. And then an average rate of change is whatever this problem is about. So in this case, it's the height of a ball. It's the ball moving from, one point to another point. That it's a rate of change. So it's how the ball is changing, what speed it's changing at. So I might say something like, the ball is moving at a rate of 80 feet every second. And that's one way I can say it, but it's not the only way I have to say it. All right, let's take a look at the back. We're going to make sure that we're all in agreement of these points on the graph. We'll go through some of these. We will definitely do some of the average rate of changes. That's where we're going to need our calculator, and you'll be finishing the rest. So the graph of T of M, note that this is function notation. T is the temperature, and if we look, it's in Fahrenheit, and M is the months since January 1st. So if this is January 1st, this is 1 month after. That means that's February, March, April, May, June, July. So I don't know if we're interested in doing that, but I'll put little things down here. So right at the beginning. This is January, this is February, March, April, May, June, July, August, September, October, November, December, and now we're back to January. All right, so let's go through these. I'm going to again pick the ones that I think might be more challenging. So explain what T of 3 represents in the context of the situation. So first, again, this is me saying that X is 3, or the months is 3. I first want to just see what that means. So I'm going to go to where it's 3, and then I'll have to move up, and I'm going to see, and it's a little blurry on the video, but it's 80. And now what I want to say is, what does this mean in context? So I got a couple of ways I could do this. Since it is April, I could say in April, or I could say after 3 months, and I'm just going to stick with that one. After 3 months, and then the Y value that I got, that's my temperature. I'll say the temperature is 80 degrees, and then I'll just put an F for Fahrenheit behind it. Okay? Oh, you know what I forgot to do? I totally forgot to mark those important points. It's early in the morning. I'm not quite awake yet. So I need to go with where it starts. Sorry, 0, 60. Where it ends, and so that's going to be 12 and 50. And anytime it turns and any x-intercept. So it turns here, and that's going to be 2 and 60. And then up here, it's going to be at 4, 100. Here's an x-intercept, so we want 5 and 0. And again, you can pause and get these. This one is about 6 and right in between 20 and 40, maybe a little closer to 40. Let's say it's 6 and, let's just go with 30. It's probably a little bit more than 30. And then this one is 7 and 0. Here's another turning one, which is 11 and 50. I'm sorry, not 50, 40. And that's what this one is. It's 40, it's not 50. Okay, now we're ready. So at what times was the temperature equal to 0? You're going to look at your graph and answer those. At what intervals of time was the temperature decreasing? So remember, here the temperature is constant, so you could put a little C. Here it's increasing. This whole stretch all the way down to the bottom is decreasing. And then we have another little increasing, and it keeps increasing here. It just kind of increases at a different rate. And then we have another little constant. So for what intervals of time was the temperature decreasing? So I'm going to be using X. You can use T for time, S for seconds, or months, I'm sorry. And then where does it start? And it decreases, 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 all the way down here, which is that 6 value. So from 4 to 6. I'm going to let you answer this one. What was the maximum temperature and when did it occur? And then this one, the point 920 is on the graph. Let's go over this one. Explain what the point means in context of this situation. So remember, 9 is your X value, and that's your time. That's your months. And 20, that's your Y value, and that's your temperature. That's your degrees. So I just want to say kind of something like I said in problem A. After 9 months, the temperature is 20 degrees, and I'll put again that F for Fahrenheit because we always have to label our answers. All right, I'll do F, you'll do G, and then I'll walk through a few of the average rate of changes, and then you're going to finish. So what was the average rate of change on the temperature on the interval from 4 to 7? So you might see it like this. These are your X's. But for most likely, you're going to see it like this. So these two could be written interchangeable. I could have written it like this as well. And I could have written this one like this. All right? But either way, these are the X values. And I'll look at my graph and figure out the Y values. So if X is 4, and I look at my graph, I get a Y value of 100. And if X is 7, I want to look at my graph, and it's 0. And again, we're finding the average rate of change, which is slope. So if you notice, the temperature decreases, so that's going to have a negative slope, but then it increases, and that's a positive slope. What I'm going to do is just find the straight shot from here to here. That's what slope is. It's a constant rate of change. And average rate of change takes this slope and averages it together, which becomes this pink line. Okay? So again, it's the y's on top. So, oh, and I already messed up. That should be a 0. So I'm going to cross those out. So when I take my y's, I want to do 100 take away 0 or a 0 take away 100. All right, sorry, I had to pause the video for a moment, and I'm going to pick back up. Somebody popped into the room. So anyway, I was talking about this, that we want to subtract our y's on top. So I can do 100 subtract zeros, a 0 subtract 100. I'll do the 100 subtract 0. But since I'm subtracting this direction, even though it's easier for me to take 7 minus 4, I will have to do 4 minus 7. And I think that's one of the biggest things that I'm seeing in the prior work, is we're subtracting the way it's easiest no matter what. But that's not going to work here. So anyway, I'm going to subtract my numerator. Here's my denominator. And again, an average rate of change is always over 1. So this is where I need to get my calculator and type in 100 divided by -3. So first my answer is going to be negative, and I should see that because to get from here to here, it's a slope that's going down, and that means it's negative. So I'm just typing in my calculator, 100 divided by 3, and I'm going to get a decimal. And behind the decimal, just go 3 numbers behind the decimal. It's a lot of 3 showing up on your calculator. And then what does this mean? It just means the temperature. And how do I know this? Because the y, again, this is all y, and y is my temperature. Let me squeeze that in here. It's the Fahrenheit, and everything on the x is my months. And again, this is an average rate of change. This whole graph is about the temperature changing. So how is it changing is what I'm explaining. The temperature is dropping, and I know it's dropping because my slope is negative 33.333 degrees. There's my F for Fahrenheit every month. 1 month, okay? So you're going to try this one, and let's just take a look at a couple of these. I'm going to give you some x values, and you're going to have to figure out the y values. So again, this just means if x is 1, what is its y value? And that would be a 1. And if x is 4, what is its y value? And that's 2. And again, we're just finding the straight shot. So I'm going to take my y's, and I'm going to subtract those on top. So I'll do 2 minus 1 because that's easier. And then that means I'll have to subtract my x's the same way. So 4 take away 1. My numerator gives me 1. My denominator gives me 3. Again, an average rate of change is always over 1. So I'll have to take my calculator, take 1 divided by 3, and I'm going to go 3 numbers behind the decimal. There's nothing to explain here. You're just doing the basic math. So last one I'm going to do with you is 6. So again, I give you the x value, and I give you the other x value, and I'm going to have to use this equation to tell me the y value. So first I'm going to have to put 1 in here, and that means I'll be taking 1 squared, which is 1, subtracting 1 again, and that gives me 0. And if I put 5 in here, 5 squared is 25, take away 5, and I get 20. And now I can do the y's on top. It is 20 minus 0 is the easiest way, and that means I will have to subtract 5 minus 1 the same way. It's not because it's easiest, it's the same way to subtract. So 20, my denominator is 4. Again, I'm going to have to divide those. I don't need a calculator to divide those. I'll get 5 over 1. And that is my average rate of change. So your job is to finish this page. And again, the directions are in OneNote or on Schoology. You can bring it to class, you can submit it to OneNote, and I'll, again, in Schoology tell you what I prefer you to do for your class, but again, it doesn't seem to matter. It'll be okay either way. All right? That's it. Have a great fall break.